Um, okay, so one of the paper, we're revising this paper right now. We're basically trying to see if we can use generative AI to mimic a sell-side analyst. So basically, we asked GPT-4 to read press release, and we asked it to write a report, and then basically sort of give a numeric predictions, right? So why do we want to use GPT-4? Because it's a very powerful model, right? This is a complicated task. We ask it to perform all kinds of things like summarize information from the press release. We ask it to yield a numerical prediction. So all these things are pretty difficult, which you definitely could not do with BERT. You may be able to do it with a small, simpler model, but what we find is that even use the most top-line model like GPT-4, you still don't achieve a perfect result. So our suspicion is that, so here basically because of the need of using large context windows, and you need to use the reasoning skills, that's why we chose a more sophisticated model. Okay, but of course, this has costed a lot of research budget. So you don't want to do it for all of your projects. The other project that I'm working on with some of the doctoral students, we're deciphering some of the languages from this Reddit forum called Wall Street Bets, right? So Wall Street Bets, these are relatively shorter social media posts. So basically here we used a smaller model called Mistral 7B. So Mistral 7B was a very good model last year, or maybe actually late 2023, it was a very good model. It performed very well, and it can actually run locally, right? So we were actually able to deploy this model on a consumer grade GPU, and we're able to just process all of the documents from our own computer for free. Okay, so again, part of the consideration is sort of from the economic consideration, and then we need to validate our results with the GPT using a small sample. We find that the correlation is actually pretty good. And part of these posts actually come with images, right? For images, we actually use a different model. We use the GPT-4V because we need these kind of vision capabilities. Of course, now nobody talks about GPT-4V because GPT-4o definitely comes with vision capabilities. All these Gemini models are multimodal, so it can consume all these pictures. The other paper is called Wisdom. I'm just going to call it Wisdom or Whims. We're still revising the title. This paper is co-authored with Shuai Chen and Ling Peng, who is my colleague. So here we actually are trying to classify the messages from stock tweets. So stock tweets is a social media platform. It's in our sample, there's over 100 million messages, right? Clearly, if we send 100 million messages into GPT, it's going to definitely bankrupt our research accounts. So what do we do, right? So we basically just random sample a small set of messages. We ask GPT-4 to help us do the classification. Is it technical analysis? Is it fundamental analysis or something else? Right? So, and then we use the input from this GPT's, we use the GPT's output as a fine-tuning data, and then we fine-tune a BERT model using these 20,000 examples. And then we classify the rest of messages using the fine-tuned BERT, right? So, so why do we do that? Because technical analysis is highly specialized. So we need a more powerful model to get the understanding of what is technical, what is fundamental analysis, right? That's why we need the GPT-4, a very powerful model, to do the first iteration of the classification. But again, remember, we don't want to bankrupt our research account. So the next step, we just use this output from GPT as training sample to fine tune a smaller model, a BERT model, just to purely focusing on the classification, right? So that saves us a ton of money, and it also helps us to get the results relatively fast, right? And actually, we find that this fine-tuned model does a pretty good job in sort of picking out the messages that are related to that are related to technical analysis and the fundamental analysis. Okay, so as you can see, for different research settings, we have different strategies of model choices. It's always a balance between accuracy, the implementation difficulty, as well as your research budget. We are not Harvard, we're not University of Chicago, so we kind of have to consider all these potential ways to save us some costs while not sacrificing too much performances. Okay, so hopefully that answers Lindsay's question. There are some advanced technique which I will skip for now. And I think this may also be a little bit outdated because, some of these techniques have already been incorporated in the newer generations of models. So maybe you don't need to do too much here. But one suggestion I want to make is that, if you're writing a prompt, you have to see if it is clear if you gave it very detailed instructions, right? So one thing I found very helpful is just to play around. You can write an initial prompt and then you can feed it into GPT and ask GPT to help you revise the prompt. So the generated prompt from GPT generally is very well structured, and also it provides very detailed instructions. Okay. Um, all right. Here I highlight some of the future exploration opportunities, at least in my point of view. I think the multimodality could be a very interesting very interesting direction of research. I think we haven't done enough to sort of understand, to sort of extract the data from the scanned images, because there was actually a lot of text from the old newspapers and things like that. So now with all these powerful tools, you can actually do a lot of OCR at fairly cheap costs. So one model I think is very good at doing that is the Gemini 2.0 Flash. So you can basically send it the pictures and ask it to extract the texts. Just a few thoughts. I haven't really got into any of this, but maybe one of you would write a paper based on these potential directions. And I think so this is super outdated. This is from last year. So all these large language models progressing very fast. Last year, GPT-4 was one of the best models. Now we have GPT-5, we have Gemini 2.5 Pro. I think for the foreseeable future, we'll see the price just keep decreasing. We will see the price of the model keep decreasing. We'll see the capability keep increasing. Although at this point, I don't expect any kind of huge leap forward in terms of model capability. I think mostly we're just going to make the model a little bit better, maybe better at the instruction following. Maybe we're going to able to change the model architecture so that it can be a little bit faster in terms of inference. It can reduce the cost of inference, so on and so forth. So I think we can do a lot to optimize. We meaning like the researchers can do a little bit to improve the model performances. But I don't, at least for me, I don't see that the model will have a huge breakthrough in the next 6 months or 12 months. But again, we already have very, very, very good performances, even out of the existing model. So I think there's already a lot that we can do even at this point. What you can there's different trade-offs in terms of models. My favorite model at this point is probably a Gemini series model like Gemini 2.5 Pro. I've used a lot. Claude, which is from Anthropic, I also think it does really a great job. So actually, I'm at the point which I already unsubscribed ChatGPT, the web services. I'm mostly just using other services that help me call the API of Claude and as well as like Gemini. Uh, but that's just my choices. Okay, again, this is outdated. So let me just so this is a very interesting chart, right? So what you can see that the cost of these for the same intelligence, for the same capability, you can see that the cost just drops by a lot, right? So one thing I want to highlight is that this is not a linear scale, this is a log scale. You can see that the drop is precipitous, right? So just to give example, the Gemini 2.0 Flash for million token output is $0.4. So it's very super cheap. And GPT $407 and $7.5. DeepSeek V3 for the output token is just $0.28. If you use the R1, which is a very famous model, is $2.19. So these costs just way, way, way cheaper compared to what you see a year ago or 2 years ago. So right now, basically, you should be not. Although I know a lot of you may be PhD students, you still have a lot of constraints. But I think if you use one of these small models to do some prototyping, you should be more than just enough. Okay. Um, so I see another question. Okay. Okay, so I think that's just a comment, right? Just a comment. Okay, all right. So I think we're at the point which we are just gonna go to the pitfalls. What are some of the things we have to watch, right? So we can't we know that these models are just machines. They actually are they're random, they're probabilistic, but so they're not perfect, right? So what are some of the things that I feel are something that we have to consider more carefully, right? Um, so in the large language model research, there's already a huge literature dedicated to safeguarding these models, make sure that they don't do crazy stuff, they don't say harmful things, so on and so forth. Um, um, and also there's a lot that has been dedicated to remove the biases from large language models. But this is not. What about finance and accounting, right? What have we done, or what we should we pay attention to? So one thing that we definitely have to pay attention to is the hallucination. Okay, hallucination is basically some of the stuff that it generates. It says it's purely not true, right? There are examples where basically people just kind of ask a question, for example, about some finance papers, right? We're finance accounting researchers. We can ask questions about finance or accounting papers. Sometimes it will give you very confident answers, but those papers simply are not there. For some reason, it came up with these kind of paper references that are completely untrue, right? This is called hallucination, right? Um, so this is something that we have to pay attention to. Sometimes GPT says things that are simply not true. There's this paper, I don't know if they have put it on the public domain. Chen et al. 2025 says that state-of-the-art large language models only return 1% of historical accounting metrics correctly, right? So this is the paper by um, Eddie Riddle and his co-authors. Eddie Riddle at Boston University. I don't know if I asked him for a draft. They haven't put it on the public domain for a very long time. I think this is actually a very important statistic. So I actually shared this statistic there, just to show that large language model is not perfect. Yeah, it's not even remotely correct when you ask it to call these financial statement data, right? Um, so how to ensure your accuracy, right? So how are you going to ensure that the model is not telling you something that is simply untrue? So oftentimes, including our paper, what we do is that we randomly sample a bunch of statements or texts from the GPT's classification results, and we then ask humans to validate it, right? So you could find an RA to do it for you. You can do it to yourself. But generally, if you can find a couple of RAs to cross-validate each other, I think you're going to feel a little bit more confident, right? So um, in our research, we find that RA's classifications overlap with GPT's classification very significantly, which boosts our confidence in GPT's results. So I think you can do the same if you're doing any research with large language models. So there are also intrinsic biases that GPT has, right? So for example, um, um, there's like if you ask GPT that people in New York, people from New York City are, you probably consider New York City people are a little bit rude, so on and so forth. Pre-K teachers are more likely to be women. So these are because, in this training data set, a lot of these biases have been baked in, right? Although a lot of effort has been made to debias GPT and Gemini, sometimes this kind of debiasing effort make the bias even worse, right? So there are definitely some biases that have been identified in the finance literature. So one paper is this paper by Leland Bybee. He was a graduate from Yale, recently joined the University of Chicago as an assistant professor of finance. He found that large language models seem to mimic the error of humans based on the news headlines. Okay. And we also have a paper, so this is co-authored with Hussein Gulen, Shuayu Chen, Clifton Green. So here we're basically trying to exhibit the extrapolation patterns. So we find that large language models, if you give it a bunch of return data and you ask to predict future returns, you'll find that this prediction of future returns has like extrapolation tendencies, right? Just very much like humans. So most of these models have been trained to reduce biases, and as I mentioned, some of these biases cannot be completely removed. Another very important bias in the setting of finance and economics is look ahead bias. If you ask GPT to predict future returns, remember these models are trained based on the whole corpus of the internet, right? So surely some of the information about future return of a company or future financial performance could have been seeped into the training data, right? So one example is that you at the end of 2019, if you ask what is the greatest risk that the firms could face, sometimes GPT will tell you that COVID risk is the biggest risk that companies will face, right? Of course, with the benefit of hindsight, we know that COVID was indeed a very big risk, right? However, we know if you're standing at 2019, you would not know that COVID would have happened, right? So this is what we call look ahead bias, right? So how do we address the look ahead bias? So one thing you could do is kind of reserve a subsample, which is purely, which is out of the knowledge cutoff data of the model, right? So on the website, you can always find what is knowledge cutoff data of each of the models. So you reserve a small sample outside of the knowledge cutoff data, and hopefully the model still perform in that subsample. The other thing you could do is that you could basically have this time-stamped model. Like, for example, you can have a model from trained using the data purely from before year 2000, and then another model trained using the data before year 2001, so on and so forth, all the way to the more recent time. Okay, several paper has been proposed these kind of models. We have Sarkar-Vafa, Levy, and also there's a recent paper by these people from Washington University at St. Louis that also does this kind of time-stamped model. So another thing that people tend to do is to remove the identity from the text. So what they're trying to do is to say, maybe once I don't tell the model that this is Microsoft, maybe it will this kind of look at bias maybe a little bit better. But I think this is probably not gonna 100% address the question. It could mitigate the problem, but it doesn't completely address the problem, right? So again, like this is something that you could potentially use as a robustness check. Just remove all the identity. For example, if you're analyzing Microsoft, just remove all this word Microsoft from your text and replace it with organization A. Okay, so hopefully this could make your look ahead bias better, and you can. This is a one way to conduct robustness check. I think that's maybe it. I think, like I'm very excited about the new technological development. I think there's lots you can do with it to conduct research in finance and accounting and also other business fields. Clearly, this is still at the very beginning of exploiting the model capabilities. I think there's a lot more you can do. So I encourage everyone to do more, to think about how to use these data, how to use these new tools, how to, to do creative research using these tools. So I would say this is sort of what I want to conclude on the note on. So with that, let me ask any questions or comments.
Yes, Professor Zhou, there are some questions in the chat box.
Okay, let me take a look. So there's a question saying, let me see. Okay, what concepts discussed today should we teach our students? I think that's a very good question. Yeah, Diane, I think let me broaden the discussion, right? Let me broaden the discussion. Maybe not think about what we discussed today that we can teach to our students, but let's think about how Gen AI will broadly impact the business world. Maybe that's a way for us to think about what the business education is going to be in the next 10 years or 20 years, right? I mean, one extremely important thing we have to keep in mind is that a lot of the tasks that used to be very difficult will be greatly simplified in the next 5-10 years in the business world, right? And even if we teach student coding before, we can give them some coding task for them to do, but now it's very simple. They can just put those answers to GPT and get a pretty good answers just right out of the simple prompts, right? So how can we teach our students the same knowledge that we taught them in the past 20, 30 years, right? I think that's a huge challenge. And frankly, I don't have a like straightforward answer. I think we need to try different ways to sort of incorporate all these new technologies, not only as part of the curriculum, but also as a part of way to convey the knowledge to students. I think this is an incredibly exciting time to learn new knowledge because it's just very, I think you can just have access to such comprehensive information in such accessible way. So I think you should, for those who really love to learn, I think this is a great time to learn new things. But also on the other hand, for some of the students, if they're unwilling to learn, they just want to have the shortcut, then maybe this kind of technology is really sort of be very unhelpful for the learning process, right? Because they can get the answers very easily. I don't know if this answers your question, but this is just some thoughts that I have. Another question, I found prompts are really subjective. Each researcher, yes, I think this is a very good question. So how can we make the prompts good, right? So it is very subjective, but I think, in my view, the process of having humans to validate your prompting results, I think this is a good step to take, at least to examine if you're getting the concept that you want to grasp, right? Of course, one thing that Jerry Holberg once told me is that, well, if you ask two RAs to do the classifications, what is the chance they're going to give you 100% overlap, right? I would say close to zero. What's the chance they're going to give you 90% of the results that are fully overlapped? I think it's also not that high, right? So if we were doing that with the RAs, why do we necessarily want to raise the bar with using large language models, right? So I think we definitely need to do validations. But on the other hand, I would not say that this should stop us from using these very powerful tools.